Hello and good day to honorable professors, the committee chairman, Professor Jongpil Chong, the committee member, Professor Moon Song Kim, and my advisory professor, Professor Hyun Seung Chu. Today, it is an honor to having you honorable professors to my presentation. First of all, my name is Haziq Hamzah from Networking Laboratory. So the title of my dissertation today is Location-Aware High Mobility Task Management in Multi-Access Edge Computing. Today, I will start with an introduction relating to MEC, and then I will explain what is HCloud and what is the task management. Then I will explain the background of the paper by defining the problem and solution space. I will then give a brief walkthrough on each part of task management, as part 1 is for task offloading and part 2 is for task migration. Lastly, I will conclude my presentation. MEC is a paradigm born with an idea of moving cloud computing technology closer to the edge of the network. MEC is one hop away with end user, so it reduces network delay. A cloud at the edge of the network is called HCloud. So HCloud has a fair amount of computational capability, and its computational resources is similar to a conventional cloud. So HCloud can host cloud-based services, but because EC is distributed across the MEC network, we need an edge orchestration between them. Task management is one of the problems in edge orchestration. Because there are more than one EC in the MEC networks, we can distribute the tasks across the ECs. For example, 100% tasks in one EC or 50% tasks in each of two ECs. The main approach, we have two. One is task offloading and one is task migration. First is the task offloading. If computational resources in end user's mobile device is insufficient, some tasks can be offloaded to HCloud for processing purpose. Second is the task migration. Let's say end user is moving currently. In order to reduce the network delay, we need to keep tasks closer to user. So if the task is becoming further with end user, we need to migrate it. Next, I will explain the background of my research based on defining the problem and solution space. We already saw in introduction about MEC, EC, and what is task management. So we should understand the problem space. Again, distributive manner of EC in MEC network, we need some orchestration. So in the orchestration problem, we have the task management, and two main approach is task management is offloading and migration. So the solution can be divided into three basic approach, which is local, global, and hybrid. For example, for resource-based approach, we only consider a local cloud EC resource such as the CPU, RAM, GPU, etc. And we make a decision to offload or migrate based on the resource. But if we have a network of EC and it is connected to a central data center, which will be the brain, we can have a global approach. My research is in hybrid approach, the hybrid solution space, because location-based approach consider both the local cloud resources and also some global parameters such as the network delay and also location of ECs. The paper is separated into two parts. First is part 1 is the task offloading, part 2 is task migration. So both parts will include problem statement, proposed idea, and also performance evaluation. I will give a brief walkthrough of each part, but because of the time constraint, to understand in details, please read the paper. So task offloading, first I will talk about the use case. So the use case can be understood here. Let me explain it. Both vehicles, so the ambulance and car, offload a specific type of task. So example, ambulance can have the e-health task and the car can offload infotainment tasks. So when offloading process begins, two factors must be taken into consideration, which is the network delay and the cloud resources. In addition, we have two offloading options. which is the central cloud that have a higher resources but high network delay, or we have the edge cloud which has a lower delay but less cloud resources. So the approach taken into solving both of these factors is called task offloading policy. In task offloading, we propose a policy called location-aware task offloading. So basically, the main goal is to reduce the service time of offloading the task. So service time here can be simply understood by the result of addition of the processing plus the network delay. So as the baseline policies only greedily select any edge cloud that has a sufficient resource to host a task, location-aware task offloading policy has an addition of location-aware algorithm, which consider a location of EC when selecting a host. So here are the location-aware algorithm of my policy. First, we identify both the location of vehicle and the edge cloud that is serving the current cell. Then we select a VM policy, for example, worst fit. So the VM policy we selected will affect the way we evaluate the available edge cloud resource. Then we check whether the edge cloud that serves the current location has sufficient resource. If it is insufficient, we find the neighbors of the initial edge cloud. If the neighbors of initial edge cloud still has insufficient resource, we will find the neighbor of neighbors of that initial edge cloud. Then lastly, we'll return the selected edge cloud immediately if a selected VM is found. First, let's evaluate the ambulance mobility, which simulated a high mobility vehicle scenario. So, due to the road traffic congestion, with the increased number of vehicles, ambulance speed decreases. So, by decreasing speed of the ambulance, it will cause longer mission time, and it will result in higher number of tasks to be offloaded, with the assuming of the onboard device continuously generating a task. Next, we will evaluate the service time versus the number of vehicles. So from the first glance, we must conclude that LATO performs better than other baseline policies because at each number of vehicles, the service time is lower. At 8,000 number of vehicles, the average speed of ambulance is dropped to 33.55 km per hour. Again, longer mission duration means more tasks need to be offloaded. So if more tasks are generated, we need more cloud resources to support the offloaded tasks. This will lead to an increasing of the processing time because a lot more tasks is needed to be processed. And if more tasks is generated, it is also means that higher network traffic can affect the network delay. It is important to create a policy that can learn the trade-offs between cloud resource and network delay in task offloading problem. But it is better to consider a hybrid solution such as our policy, location-aware task offloading. So in part 2, I will talk about the task migration. Similar to part 1, I will first talk about the use case in task migration problem. Because we want a high mobility use case, as in part 1, we use an ambulance scenario. The biggest difference with task offloading is that we consider the task is already in the edge cloud. So, as an onboard equipment is streaming the service from EC1, as in the figure, it may follow different paths to the EC1. So tasks will follow different paths in order to avoid network congestion. As ambulance moves and changes, ambulance moves, the network path changes will occur. So we need a task migration to be performed in order to maintain the quality of service. That is why we use approach of task migration. So we propose mobility-aware service migration and MASMN that guarantees the chosen candidate HCloud will have a minimum routing cost and have a fair amount of migration costs. The routing cost and the migration cost is added to become the network cost. So here are the algorithms to minimize the routing cost. First, we consider the top K subset path. Then we calculate the routing cost of all the paths. Then we choose the top K subset path based on Yen's K shortest path algorithm. After that, we will have the minimum routing cost. Then our heuristic will repeat the process of baseline heuristic on finding the overall closest HCloud. So the advantage of MASMN is that when flow is to be assigned, the minimum routing cost of the subset path will not be changed because we have already the optimal subset path. So because of time constraint, I will only share the evaluation about HCloud proportion against the routing cost. As the HCloud proportion increases, so first of all, this is how we calculate the HCloud proportion by dividing the number of HClouds to the number of aggregation routers and times 100. So as the HCloud proportion increases, the number of HCloud selection also will increase. So an increased number of selections means that there are other subset paths that has lower routing costs that we need to find. So our heuristic mostly is able to reduce the routing cost as the HCloud proportion increases. The idea of task migration in our research is rather simple because compared to the task offloading, because we did not simulate the computational resources. So to conclude my presentation today, we already covered both task management problem, which are task offloading and task migration. Both of the task management problem specifically considers highly mobile ambulance use case. And in task offloading, we propose a location-aware task offloading policy to reduce the service time. And in task migration, we propose a mobility-aware service migration algorithm to reduce the routing cost. So once again, thanks to honorable professors who is willing to sit down and listen to my presentation. Please feel free to ask me any question. I will end my presentation here. Have a nice day. Thank you, and thank you.